computer, so it's taking a minute longer to manage what's going on. Here we go, 48. Okay, again, crucial, you've got to know what you're looking at. We're looking at f prime. So there. And then you've got to pay attention to what they're asking about. So you're looking at f prime. They're asking about f. Every single answer talks about f. So you just go one by one. And you ask yourself, one by one, are these true or false? Item A, f has a local minimum. That means the same thing as relative at x equals c. I'm going to go type again. F has a local minimum at x equals c. So raise your hand if you're prepared to tell me whether that is true or false. F has a local minimum at x equals c. There we go. Hands up for a minute. Get a few more. F has a local minimum at x equals c. About half of you. Let's try Josh.
It'd be false.
Tell me why, Josh.
Because that would be the maximum because it's changing from positive to negative.
Nicely done. So we would say f of x has a local maximum at x equals c because f prime of x changes positive to negative at x equals c. What I've typed in purple is a true statement. What is on the question is a false statement. I want to talk more about that. I fight my mouse. Get it to work. Yeah, please, Brianna.
Isn't point B a local maximum for f prime of x, not x?
That is perfect. So let's type that out. Two more for Brianna. So f prime of x has a local max at x equal b because f prime of x changes increase to decrease at x equal b. That was perfect. So statement B is also false because it's not the blue statement. The blue statement is the true version of statement B. We want to talk more about that. Okay, let's go on to C. So everyone who knows, C, true or false, hands up. Hand down for a second. Let's give people a chance to think. Feel free to talk to each other. What's happening on C?
That's what I think about. Like at this What was that going? So yeah, I think it's because that would be the point where it changes from. That's the point where it changes from a negative slope to a positive slope, which means that it would change the direction.
So what minimum is f has a this would be point of inflection. This graph is not.
Yeah, but saying the graph of f has a point of inflection. It's saying on the graph of f, where is the point of inflection? Yeah, hey, you literally just said that. You're like, this would be a point of inflection if it was A on f. This is what it would look like, right? This is when it changes from, this is all negative, right? This is all positive. This is where it changes from having a negative slope to a positive slope.
Okay, pause for a minute.
That's where it changes from going.
Okay, hands up. Who knows whether C is true or false? Hands up. Who knows whether C is true or false? Let's go River.
True.
So River votes true. Raise your hand if you're voting true for that one. 2 points for the true voters. Raise your hand if you're voting false. You have 4 points for the false voter. So we actually already talked about C. It's up here in purple. At x equals c, f prime is changing positive to negative. Because these are y coordinates that are positive right here. These are y coordinates that are negative on f prime. When f prime changes positive to negative, that means f, we can't see f, but that means f would be changing from increase to decrease, which means f would have an L max at x equals c. Please, ma'am.
Isn't the purple for answer choice A, which is talking about point C, not for answer choice C, which is talking about point A?
Oh, that would be important since I messed that up big time. My explanation was very accurate for point C, but 4 points for Brianna, because it is talking about point A. It's kind of the opposite though. Like if I were to type up that one, if I can get it to work, it's going to be a near copy of this. Except that mouse just won't work. Apologize for the technology. Here we go. That means f has a local minimum at x equal a, not an inflection point. Because f prime changes from negative to positive at x equal a. Julia, please.
So, just the point where it says A, comma, F of A, that just means the point at A?
Yes. So we practiced that a little bit earlier, but not too much. This is the x coordinate. This is simply the y coordinate on f at that point. Wherever the f graph is, we don't know what f looks like. So this is a point. So instead of saying x equal a, it's really, x comma y.
Okay.
Got it? Good, Julia?
Yeah.
Two more. Other questions? I check my time, we're almost out. Look at this. You've not seen this before, let me point it out to you. So look here. Okay, your Danica's chart does not show this, but we will eventually study this idea. These are relative values. That means they can be anything. It's just how they relate to each other that's important. It's not important what you call them, okay? So I've got an extra column on mine, over here, capital F. That's because sometimes we'll talk about a whole nother function, but the pattern never changes, so it's not harder. It's not any harder. Look at the pattern. These three relate by this relationship right here. That's how they relate to each other. That means I could put over in this column a concave up and a concave down. So at x equal a, where f prime is changing negative to positive, this other function called capital F would be changing concavity and would have an inflection point. But that's not this function, small f. Okay, the bell's going to ring. Stay with me for a second. So this one's also false. The correct statement is item B. F has an inflection point, D, sorry, point B. Struggles. No, you're good. So item D is the correct answer because at point B, F prime changes from increase to decrease, which would tell you that if you could see the graph of F, you would see the graph of F changing concavity. Good job, you guys. Cool.